Now the function is back again with the composite function. The phi x is the composite of h of f of gx, and the value at pi by 3 is ours in term of 10. Now what is fx here? It is root of x, gx is 10x and hx is here. So first let us calculate what is this phi x actually. So this is h of f of g of x. So let us see what is this exactly. Gx is 10x and fx is root x. So we have this as 10x, and again f is root of x. So this will have a root of 10x, and definitely this is hx. So this is equal to 1 minus tan of x upon 1 plus tan of x. So let us see the value at pi by 3. The value at pi by 3 is definitely 1 minus root 3 upon 1 plus root 3, but we have to express this value in terms of tan of these angles. So let us check it out. You can notice this is tan 45 minus tan 60 upon 1 plus tan 45 tan 60. So this is tan 45 minus 16. So this is minus of tan 15 degree. So this can be written as tan of pi minus pi by 12. Pi by 12 is 15 degree. So this is actually equal to tan of 11 pi by 12. So again, looking at the option, you can straight away look at that third is the correct option. Let us move to the next problem. A question from the complex number clubbed with the concept of locus. Again a sitter, easier one here. We have to find out this equation represent a line or a circle or a line passing through the origin and having slope 1. So what we want to do here, we want to find out the locus. So we are substituting x plus iota y in place of z. So just by substituting here and taking the modulus on both the sides, we have, now if we take the square on both the sides, let's see what we are going to have here. It is x square plus y minus 1 whole square is equal to x minus 1 whole square plus y square. Now if you square it out, we will have here minus 2y which is left, x square will get cancelled out, y square and 1 will get cancelled out, and here we will have minus 2x. So the required locus is x minus y is equal to 0, or a line passing through origin and having slope 1. So here we are, the fourth option is the correct one. Let's move to the last problem of this paper. Here's the question from the trigonometric equation. The question seems to be complicated because here it is the 4th degree and here we have cos of 3x. But again, if you check the left hand side and right hand side, if you compare it, you can see the left hand side is always greater than or equal to 1, because 1 is added with a positive value, but the right hand side RHS is always lesser than 1. Now the equality will hold only if the sign x becomes 0 and at the same time cos of 3x square is equal to 1. Now let us say what are the solutions which are satisfying both these. If you expand this, we can have 4 cos cube x minus 3 cos x whole square is equal to 1, and again taking cos common here, we have 4 cos square x minus 3 whole square is equal to 1. Now, when sine is 0, this cos square will be definitely equal to 1. So, this is 1. So, from here we have 4 cos square x minus 3 whole square is equal to 1. So, let us see, that means this will give you value either this minus 3 is equal to 1 or minus 1. Let us say if it is 1, then we have this is equal to 1, which is again satisfying. So, when sine is 0, cos is 1. So, definitely all the values when sine is 0 are satisfying in this interval. So, when sine is 0, when is sine 0? Sine is 0 at the multiple of pi, and if you see this interval, we have value 0, and again there is pi and minus pi. So, we have 0 one of the value, and again plus minus pi is also there, and two more values are here, that is plus minus 2 pi. So, there are in total 5 values which are going to satisfy it, and you can easily check it out. All these values, they are going to satisfy in the original equation. So, the correct option here is option number 2. So, we are done with this paper, and I hope you must be getting plenty of marks here, because it was definitely a question paper to crack. All the best to everyone.